Sweet, okay guys, so today we're going to talk about manometers. They're a very simple instrument. Very simply, they are a tube which has liquid inside, and what they do is measure pressure in a gas, and I'm going to show you how right now. Usually the liquid is, or it used to be, mercury, but in here we've got water with potassium permanganate so you can see it, but let's pretend that it's mercury. And at the moment the tubes here are open, and as you can see, when the tubes are open, the pressure on each side is equal. The pressure from there is the same as the pressure from there. Now, what is that pressure? It's atmospheric pressure. So right now, an atmospheric pressure, by the way, is at 2,000 meters is 600 milligrams mercury, but at sea level it's about 760. Because you're further down, there's more air particles pressing down, creating more pressure. So at this very point, when the liquids are even, the pressure in the gas on this side is atmospheric, and on this side it's atmospheric pressure. Now I'm going to change the pressure. I'm going to take a syringe. Right? Now I'm just going to extend the syringe out, and I'm going to place it in there. Now we're going to do this in another lesson, but Boyle's law states that as you decrease volume, you increase pressure. That's because we squidge all of those particles into a smaller place. So what I'm going to do on this side is I'm going to decrease the volume in this gas on this side, which is going to increase the pressure, which means that this will have more pressure than atmospheric pressure, which will result in that moving up. There we go. So the pressure in this side is more than atmospheric pressure. It's more than 600. And to calculate how much more it is, what we do is we add the difference onto atmospheric pressure. So here the difference is, it's gone from 5 to 10, 15, let's call it 20 centimetres difference. Just to make it nice and simple, which is 200 millimetre difference. So we add that to our 600. So the pressure is 800 millimetres mercury. It's more than atmospheric pressure here because it's fighting against it, it's pushing it. Yeah? Don't forget pressure, force over an area, and it stayed there when the weight, don't forget weight is a force, is equaling to that pressure. Now, we can then take it back, and we can then go the other way. We can now make the volume in here larger. Which has decreased the pressure in this side. The difference again is 200 millimetres. So what we do, we know it's less because atmospheric pressure has been able to push the liquid up. So we know that here is less than atmospheric pressure. So 600 minus 200, which is 400. Yeah? So when you're calculating pressure in a liquid, you need to first get the difference in the height and then decide if the pressure is more than atmospheric pressure, like so, and then you add the difference to atmospheric pressure, or if it's less than atmospheric pressure, if atmospheric pressure is pushing it, then you take the difference in height of the liquids away from atmospheric pressure. And those are the units we are working with. Okay? I'm going to send you a quiz to go with that lesson, and good luck. All the best.